Okay, here's the game, friends. If you are integrating some function from somewhere to infinity, or from negative infinity to somewhere, or negative infinity to infinity, these are all one type of improper integral. Improper because I cannot just shove infinity in to a problem and evaluate it.
You sure he's not pushing hard enough?
What?
You sure he's not pushing hard enough to give it work?
You should use them.
There you go. Nice. So, if I try harder next time, I live it up and push harder, and it'll go in there. Now, here's the game. What we're going to do, friends, for instance, let's look at this feller here. We're going to take the antiderivative, of course, which would be what? F of a, f of x, Mr. Groom, cap f of x, from a to infinity, yes? Like we always do. And this is what we're going to do, Audra. We're going to take the limit as x approaches infinity of f of x minus f of a. Ta-da! Now, if that limit is a finite number, then the thing has area. If it's infinity, it's an infinite area, and yeah, we're screwed. We're not really screwed, you're just done. It has infinite area. So the idea here is that the limit has to go to a finite number. By the way, 99.9% of the time, that limit will be 0 or infinity. Once in a blue moon, something weird might happen otherwise, but it's almost always 0 or infinity. Almost always. Okay? So there you have it. Now, what would it be for the middle one, of course? The middle one, of course, would be the same deal, except you'd go from negative infinity to a, so it'd be f of a minus the limit as x approaches neg infinity of f of x. Nice. And then, of course, the other one is like unto it. The problem with the other one, the problem with this one, someone might say, oh, this should be this, the limit as x approaches infinity of x minus the limit as x approaches negative infinity of f of x. The problem is that isn't always true. This one's a little weird. This one, in fact, usually will need to be rewritten as the sum of two separate integrals. And typically, Riley, what number is conveniently located, I'm going to say halfway, but that's not true. Halfway between negative infinity and infinity. Yeah. So 99% of the time you're going to use 0 as your a value. That's not to say you couldn't use 1 as your a value or something else, or 2.5, but typically speaking. That's it. Now notice there's a lot of just this is kind of how you do it. Obviously we'll do a few examples of these guys, but I mean, it's just not a whole lot to this deal. Does that make sense? I mean, yeah, I guess. They fly. Audrey, did you have stats last year? Oh, you had stats last year. Nice. Do you remember last year when we did the normal distribution?
Oh, please don't ask me.
No, nobody's gonna ask you anything. But the normal distribution is more or less, and Mr. Grimm doesn't remember it off the top of his head because I never graph it, except in a program. It is something like this: 1 over 2 pi sigma e to the minus x squared over sigma squared. Well, that's actually x minus mu squared. X minus mu squared over sigma squared. Yeah, that's great. Mr. Groom, does that have an integral in closed form? You know it doesn't. It doesn't have a nice integral. Here's the game, though. It actually exists all from here to here. That's nice. Notice it's not equal to infinity. That would be a problem, right? Okay? So the game is this. I know that the area under this curve has to be 1. That's just a fact. Because it has to do with probability. So the area from negative infinity to infinity is, well, it's 1. Now, interestingly enough, notice the negative x squared routine right here going on. How fast does that drop off towards 0? Really fast. Now, for my SAR student here from last year, stats. Dear, if I were talking about the standard normal distribution, standard normal had, what happened? The standard normal my fat gut got in the road again. The standard normal distribution had a sigma of 1, and it had a mean of 0, yes?
Okay.
And so this was just centered at 0. And you might recall, what was the entrance to Freakville always, dear?
Wasn't it 2? 3.
2 for sure, but -3, you know you're way out there, right? From here out, what percent is out here? Almost nothing. How close to infinity are you at that point?
You're not very close to infinity.
That's correct, dear, but you're almost at 0 already. If you are 3 standard deviations fatter than the average person, you are huge. If you are 3 standard deviations shorter than the average person, you're freakishly short. If you're, wow, okay. I don't know, how tall are you, 5 foot?
5'4" and 3/4.
You're not even that short.
I know. That's what I said.
Why'd you look at her that weird?
Because he's
Okay.
so freakishly tall.
Okay, here's the game. In the United States of America, 5'6" is the average height for women. The standard deviation of 2 inches. So unless you're shorter than 5 feet tall, you're not freakishly short. If you're taller than 6 feet tall as a girl, you're freakishly tall. Like what percent is taller than 6 feet? Less than I have to do the math in my head, less than 0.15% of women are taller than 6 feet tall, and the same amount is less than 5 feet tall. That is why when you see a girl who's 6'5" or something, you do one of these numbers, right? Because it's just weird. You do the same thing with a 4'7" girl, but you wouldn't see them. You'd just step on them. Okay? So, it's weird. Okay? Now, that is almost nothing. From there to infinity, what do you get? Nothing more, to be honest with you. Okay? And so, this equation here is one of the ones where we will do this a lot. Now, the problem is, of course, this thing does not have an integral in closed form. So, you'd have to use midpoint notation and things of this nature to figure it out. In this particular situation here, what you'd do, of course, is you would go from negative infinity to 0. And whatever you got for the answer there, you times it by 2 because it's nice and symmetric, yes? And it's beautiful. Now, I'm not going to do that one because it can't be done in closed form. So let me do one that can be done, okay? E to the negative 2x, check it out, from 1 to infinity. Let's do it. Mr. Groom, does it converge? Yes. How do you know? Well, I don't know yet, but I'll pretend like I know. All right? We know she drops like a rock, yes? And what we're interested in is from here to infinity. So what is the antiderivative of e to the negative 2x? How would I do that?
Negative e.
I don't know either, so I would use u substitution. And then I would say du is equal to negative 2 dx. So in other words, I have negative a half of a u, yes? A du, I mean. So now I have negative a half. Well, negative 1/2 of e to the u du, yes? So what's my answer going to be? Negative 1/2 e to the negative 2x, right? And then let's just evaluate that thing from 1 to infinity. Okay, so let's do this. What is the limit as x approaches infinity of negative a half e to the negative 2x minus a minus a half e to the minus 2? Right?
Why did you do the second one?
I put a 1 in, didn't I?
Oh, that's it.
I put a 1 in for x? Yeah? Does that make sense?
Is it like so the e u du, is it e to the u times du, or is it e to the u times du? Like I said it's the exact same, but yes, okay, that's what I thought. Thank you.
It's my fault. I'm just a sloppy, horrible human. Now, what is the limit of negative a half e to the negative 2x as x goes to infinity? 0. How'd you know that?
I guessed.
That's crazy. E to the negative 2x means put e to the 2x in the basement, yes? If you have 1 over 2 e to the 2x, that fraction is going to 0 in a hurry, yes? Correct. So this is 0. One could also graph it at that point, couldn't one? And so my answer, you see, friends, is this amount right here. That's obviously a decimal. You could punch it out, point whatever it is, but that's it. That's all. Well, that's perfect right here. That's perfect. The decimal would be an approximate value, but that's perfect. Did you go to the office? Where'd you go?
To make coffees and fill up your water.
Thank you, dear. You gonna go anywhere fun for a party tonight?
No. I'm not. I'm delivering cookie dough after softball practice.
Seriously? Mom, Dad's not taking you out or anything?
Oh, thank you. Well, I have 76 boxes to deliver, so it's gonna take all of us.
Oh. That's pretty crazy. That's a lot of boxes of dough.
Yeah.
All right.
You're not kidding.
All right. Questions, comments, concerns? Let's do another one.
So that's just the area
That's the area.
from 1 to infinity.
From 1 to infinity. Wait, Mr. Grimm, I don't buy that, Mr. Grimm. Let's go to Desmos. What was it?
1,500.
It was 1/2.
No, the original equation was E.
Oh, to the negative 2x.
Taylor, with the cookie dough fundraiser, do you get all of that to like pay off your fees, or does it go to the team? So like, you raised a lot of money, and like other people still like 2 boxes.
Yeah, it's really annoying too because I haven't gotten anything from the money that I raised. But it's
Wait, so you sold 76 boxes? By
but
yourself?
and some girls didn't sell any. Yeah.
That's $1,520.
This whole area from here all the way to infinity. Point whatever I said a minute ago. What was it? Don't worry, I'll look it up.
No, 1/2.
Well, you're just too busy yabbering. It's fine. .067. That's the total amount of area, all the way to infinity.
If you just put in E, will Desmos know what E
I think so. That's not much, is it? Look, this is what it actually looks like. See?
Hardly any.
It touched a little bit. Nice.
So like it never touches 0, right? Or like that's crazy.
So how can it? Does it
But at some point,
Infinite.
at some point in Excel, if you kept typing in like e to the negative, let's say you put in x equals 100, e to the negative 200 is 1 over e to the 200. And 1 over e to the 200 is 0.00 forever. And in fact, Excel would tell you to take a flying leap and just call it 0. Right? It's a 0. So the idea is how close we'll get. It's gone. So kind of like this back in the day, they always asked us, to the downwind to Hanford, when did you move back? Well, never. Well, here's the deal. Even if you spilled a little plutonium right here, when you come back eventually, it'd be far enough down in theory, I could never actually get the Geiger counter to go off, maybe. But I know there's still some there, because it's a half of 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 a half. Eventually, I can't detect it anymore. It doesn't mean it's gone. Okay? Same way following someone in the bathroom or someone's cutting onions in the kitchen, same basic premise. Eventually it gets down to where I can't tell anymore, it doesn't mean it's gone. It's pretty mind-blowing. This is one type of improper interval. Let's do another example of this. The classic is always, hey, let's integrate 1 over x from 0 to infinity. Let's try that. Actually, don't go from 0. Let's go from 1 to infinity. Yeah, let's do 1 to infinity. 0 would have another problem, yes? Why? It's asymptote. That's weird. So what's the antiderivative? The ln of x, obviously. Yes? From 1 to infinity. So we take the limit as x approaches infinity of ln of x. Oops. Minus 0. Because the ln of 1 is 0. Yes? That make sense? Are you sad?
No.
Okay. Maybe it's just me projecting.
Are you sad? You seem sad.
I'm tired today, morning, sad. Woke up late. Not late, just like it was 5:45 and I was pissed, or 6:45 and I was pissed that I'd overslept so late. So I didn't have time for breakfast. I stopped at McDonald's and grabbed something on the way in. Just don't like that. I'm rushed in the morning. I hate that feeling. I like to relax. Hate it. All right, sorry, enough whining. What happens to the natural log as x goes to infinity? It does not go to 0. Grab your calculator, graph ln of x, and see what happens to it as x gets huge. Okay. Did you do your own fingernails?
I did. I did it for one of the colleges I got into was Yellow and Blue, and I went to like a reception, so I like did this cool course. It was really cute.
Did you go to it? Are you going to that one?
No, I'm not.
Network are orange and black, so she's.
You going to Oregon State now? Where were you going to go?
So it's UC San Diego, which is like my dream school, but it's super expensive and super far away.
It is very expensive. It keeps going up, doesn't it?
Yeah.
In other words, it goes to
Infinity?
nice. Infinity minus 0, last I checked, was infinity. Uh-oh. Does not converge is what the big kids mean. But what that really means, it has is infinite area. That's what it really means, okay? But the big kids will say, does not converge. And that's how I want it written.
You want it does not converge.
But in your mind, you can say, Jesus, because it's infinite area, yes?
Well, aren't they technically all infinite area? But like,
No.
you just can't detect that in zero.
No, the last one was finite because it went to 0. Yes, this one is not going to 0. All right?
Okay.
But you're like, well, wait, Mr. Groom, this seems weird because I feel like 1 over x looks like this. And it's headed towards 0. I agree with you. It turns out there's a rule for this, friends. 1 over x to the p converges, that is, has finite area, if p is bigger than 1. So, for instance, 1 over x squared converges. 1 over x cubed converges. 1 over x to the first power does not converge. 1 over the square root of x does not converge. You see this? That's it. It's a rule. You can memorize it if you'd like.
I will.
No. Yeah, you call it Grimm's rule. I don't have a rule named after me yet. That's good.
Lots of rules, man. Everything you tell us, so we have to like follow. That's a good.
Oh, okay.
Even like writing notes do not converge. That's a groom's rule.
You're so funny. Ouch. All right. Here is a fun one. Ooh. Why'd you put 11 on top? To see if you're paying attention, whiny baby head.
That was me. He was after me.
Does this feller converge? Let's go from 12 to infinity. By the way, why not 0?
Because 0 goes.
No, 0 is fine. But what's wrong between 0 and infinity? There's a problem.
There's an asymptote.
There's an asymptote at 11, so that's going to be an issue. Yes? So let's not do that. All right, so what is the antiderivative of this beast?
U substitution.
U substitution. I love it. That's hot. So this could be rewritten as 11 over u squared du, yes? Which of course is the same as u to the minus 2 du, yes? What's the antiderivative of u to the minus 2?
It's just U.
Negative 11 u to the minus 1, yes? Right? You add 1 to the exponent, divide by that exponent, yes? And of course that is really just negative 11 over x minus 11. Just like that, yes? So let's evaluate that thing, shall we? take the limit as x approaches infinity, minus, and then 11, well, it's just 11, isn't it? I guess I'll do this just because I'm a nice fella. Shh, don't tell anybody. That's going to be 11 over 1, is plus 11, yeah? All right? But what happens here? What happens to this function as x gets huge, friends? What's that? It gets tiny. It approaches what? So the answer is 11. C. 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 Seriously, you're making me look sad today. You're making me feel sad.
I'm good.
You're good?
Yeah.
Okay.
I have a question.
Yes, dear.
What's there on your hand?
Copy of check. So, Lion Pride, whatever night when they had the 8th graders here. So I wrote a check for the pizza, and then supposed to get reimbursed. So I turned it in. So first of all, she's like, "How do I know this was that you paid this?" I'm like, "It's a receipt. I need the check." "You don't need the check. Here's the receipt." Okay, whatever. So then yesterday she sends me this thing. Yeah, she says she does need the check. So now I have to go print off a copy of the friggin' check, bring it in, so that I can get reimbursed. It's so ridiculous.
That was a lot of pizza.
Yeah. Well, not for no. I didn't buy that piece. I bought for the for the auto kids. But I bought
'Cause that was like
3 Sunshine Larges, which are not cheap. They are not. That's like $75, $80 worth of pieces. Something ridiculous. It's a lot. Anyways, whatever. So 11. That is our final answer. By the way, notice that I had 11 over x to the second power. Did you see that? Well, there's supposed to be quotation marks. You see that? Even though it wasn't x itself, it was x minus 11 squared. What'd you get? Is it funny?
No, it's stressful. People
not
are dumb. Woo!
Do you need to go hit somebody?
no.
Yeah,
I'm
I'll
just
go
gonna
hit
ignore
him.
that.
Was that Caleb?
No, no.
I'll go beat him.
Caleb's not here today.
I just typed up the entire assembly during 3rd period because the person who's helping me decided not to type it up. Somebody just emailed me asking if they could be put in the assembly tomorrow.
No, absolutely not. No, no. Say no. Here's this is the word. This is the word, dear. Say it with me. No.
She's literally in
Self-reference.
leadership, and she wants me to put her in.
No.
Yeah.
Say no.
Secretary.
No.
For what though?
No.
For
Yeah.
Because Morp's coming up.
Oh.
And I was singing it, and
Question.
we didn't ask in advance.
Question. Band people. Next period. Yes.
We don't, not today. It's 6th period. It's Thursday today.
Freaking.
What?
I just emailed her and she said yes. I'll have it done tomorrow.
What are you talking
Well, I have a bunch of cans by the shop need to be hauled away. Cans and bottles, and she said concert band will take care of it.
Yeah, concert band will take care of it.
Oh, maybe they're doing it right now.
Yeah, concert band.
She's not here today?
The double dippers. She's not here today. So actually they probably won't take care of it because they won't know.
She probably put it in her sub notes.
Okay. Well, whatever. I just tripped over this stupid bag again. It's pissing me off. And okay, thanks. Okay, I'm sorry. I was just ranting. Hey,
You
Mr.
can
Gill.
always just give it to one of us and we can take it.
Oh, you want to go get it? It's from the shop. I could just have Tate. I got my TA to obtate it when she gets back. She can go get something done.
Probably good shit.
Yeah. I'll make her walk all the way around the outside the building. Where do you take it to?
They put the cans like in the trap over there, like the garbage chained up off the.
Okay. Anyway, all right. The other kind of problem is this kind. 1 over square root of x. And you're like, Mr. Groom, this I know doesn't converge. Hold on to your horses, friends. I didn't say anything about going to infinity. Now, is this a problem at 0? Yes. Yes, it is. So, check it out. If I were to antiderivatate this thing, what do I get? This is, remember, this is x to the minus a half, yes? When you antiderivatate that, what do you get?
1/2 ln.
No, oh wait, 2. Oh, it's negative, yeah, that's right.
You add a half, add 1, you get positive a half,
Yeah.
divide by half, times by 2, yes? Now we're going to evaluate that from 0 to 5, yes? So it's 2 squirt 5 minus the limit as x approaches 0 of 2 squirt x. Now look at this. Can you plug 0 into this fella? Is that okay to plug 0 into square root of x? Okay, is there a limit? Square root of x. Yes or no? Square root of x. Can you take the square root of 0? Yes, it's called 0. So the limit of this fella is 0. Then I get 2 square root of 5. In other words, that has a finite area. That's my answer right there. That will not always be true. That will not always be true.
Why'd you put them in a different order?
Huh?
You put the limit 1 second.
Ooh, because the problem occurred at 0, not at 5. You with me? If you look back here, watch back on this one here. Where was the problem on this problem? The problem was on the top one, yes? The first one?
Yeah.
Where was the problem on this fella? Oh, this fella. On the top one?
Mm-hmm.
We should probably do one of the other ones too. Let's do that. Mr. Graham, do me another one. All right, cool. E to the 3x dx negative infinity to 0. That's hot. Nice. Hey, what do we do? A little u substitution, yes? Can you do it in your head yet? What's it going to be? Hey. Okay, I need to run an errand, you guys. You shouldn't get in trouble because you're Tay and you're with Tay. So. Sorry, Ryan. I mean, let's be honest. Whatever. So in front of the shop, there's a big bag of cans and bottles and crap. It needs to be hauled down around. Where do you want me to put them? Out by the. It's like haul them all the way around the outside of school, and then come in like by the back side of like.
You have to have a key to open it up.
I know. I'm going to tell them where to go to get that. I think.
Okay.
Anyway, okay. In front of the shop,
Cans?
there's a can. There's a big. Then stop down at the main office
Okay.
and ask Mrs. Hall on the booper to get the key for the recycling cage thing, and then go put them in the recycling cage thing, and then check my mail while you're down there. You probably want to wash your hands first, and then give
And
Miss.
then get escorted back.
Probably.
We can let you in.
I'll let you know if you come back this way, and then give Mrs. Hall this receipt before I forget. And if she
You want to know what
nags
she's going to tell you? She's going to tell you need to fill out a form.
And then, no, this receipt's okay. This is our monthly laundry receipt. But she will yell at you about the fact that I have to give her a check tomorrow. And I said, yes, I know, it's on my hand. To remember it. Okay?
Okay.
You got it? You good now?
Yep.
Hey, have fun. Thank you.
Yep.
All right. So what would the antiderivative be here?
1/3.
1/3. E to the 3x. Beautiful. So it's 1/3 minus, right? The limit as x approaches negative infinity, 1/3 e to the 3x. What happens as this dude approaches negative infinity? It goes to, it does not go to negative infinity, it goes to 0, doesn't it?
Yes.
Yes? We go into 0, so I should probably keep drinking this for a little while. Then I'll switch over to water pretty soon. All right, yeah, it goes to 0. So the answer is?
1/3.
The answer is 1/3. Bam. That make more sense?
So you just go based on the rules that you wrote of the improper integrals for the order.
Yeah. Notice that this, the Groom's rules, yes.
Wait.
Now watch this one here. This one's going to be mind-blowing. You already said this one doesn't converge. Hold your horses. What is the antiderivative of this guy? We already basically did this problem. Antiderivative 1 over x is what? 4 ln x. There it is. That seems straightforward enough. 0 to 4. Now where's the ith-u? Where was the ith-u originally? Was it at 0 or was it at 2?
0.
It was 0. It's a freaking asymptote, yes? So I'm going to take 4 ln 4 minus the limit x approaches a goose egg of 4 ln of x. What happens to ln of x as you approach 0? It goes to,
1.
I don't know, you better look at it. Graph ln x on your calculator. What happens to ln of x? I guess you go to infinity, dear, but we're talking about as you approach 0. It
Undefined.
still goes to infinity, but it's the -1.
It doesn't, yeah, it just says undefined.
No, I didn't say to take it. I said graph it. Graph ln of x, yes? And what happens is you go towards 0. It goes to -infinity, yes? So what does that say? It's 4 ln of x, or 4, I mean, minus the minus infinity. No, it's not. The answer is does not converge. You with me? Now listen, the fact that it does not exist may or may not mean it goes to infinity. You with me, kid? Does that make sense?
Okay.
I mean, because it could be a hole, right? You don't know. But if you graph it, you're looking at this. You're looking at the limit, and the limit happens to be -infinity. By the way, any kind of infinity does not converge. Yes, it's a problem. Got it? Cool. Yes, dear.
Okay, so the last one, right before this one, where there's a problem on the top and the bottom, shouldn't you do the limit of each one minus, like, limit of something minus limit of something? That's what it says in the... We've had f of x infinity to infinity was... Both of them, do you know what I'm talking about?
Yeah, but I haven't done any of those ones yet.
I thought, okay. Well then,
I don't think I did any of those yet.
so you're just saying a is the 0, okay.
Yeah, I think. No, okay. Is that okay?
Okay.
Mr. Kim has another question. What about this equation right here? 1 over x to the 4 from -infinity to infinity. Oh dear. How on earth do I solve it? I don't know. Doesn't really matter what's the first thing you use, you can do it one way or the other. Let's do the antiderivative first, shall we? What do you get?
Oh, it's
1/5.
Third or fifth? Because you add 1 and then divide?
It's not -4.
It's a -4. 1 over x to the 4 is x to the -4, right?
Oh, okay.
So then, here's my antiderivative. And you're like, oh, this is going to suck. Look what happens if you do this. Look what you get. Oops, this is x to the -3, I mean, right? What's going to happen when I do this? You're going to get a bunch of zeros. You're going to get 0 minus 0. You with me? But that's not the right answer. Look at the graph. Any idiot can see from the graph, even a freshman can see from the graph, that 1 divided by x to the 4th.
It's probably for you.
Yo, what's up? There's a... Okay, right in front of the shop door, there's a giant green engine, yes? You see that giant green engine? It's like taller than I am. It's like right by the shop. And right by there's a giant bag of cans. Okay, then Miss Freshner must have taken care of it. There, you cannot see right by that giant engine, there's not a giant bag of cans. Like a bag of cans is literally the size of you. All right then. Then Miss Freshner must have picked them up. Thank you. Swing back around the side of my house. Oh, actually, go down to the office and grab my mail and hand that receipt to Mrs. What's-her-schnutz and have them walk you back or something. Okay, so I don't get in trouble. Thanks. Bye. Yeah, there's not a giant box of cans the same size as her. All right. Yeah. Yeah. Is this going to be a problem? Yeah. Where's there a problem on this one? At 0. You with me? Now, obviously, it's going out to the ends, it's going to converge, yes? Because it's 1 over x to the 4th, right? But here in the middle, we have a problem, don't we? You see this? So even though the thing says there's 0 area, it's lying to you. And you would have caught that, dear, if you'd have said this. if you'd have said this, if you'd have said, let's go from negative infinity to 0, you see, of this, then you would have done this number. And then you would have said, oh, that's a 0. And then you would have said, all right, let's take the limit as x approaches 0 of negative 1/3 x to the minus 3 minus the limit as x approaches negative infinity of negative 1/3 x to the minus 3. This is 0, so that's handy, but this does not converge. This is why, one of the many places why you need a graphing calculator. I cannot stress that enough. You should graph every problem and see, does it look like it has finite area? Yes or no? If it looks like it does, then it might. Then it might. Sorry, my big gut got in the road again. It's ridiculous. Anyway, what I was trying to say was that if it looks like it does, it may or may not. But if it clearly does not have area, like this one has an asymptote there, no. Okay, you need to check and see. That's a big deal. Now I'm going to change one thing on this problem in a minute, and you're going to be like, no way, Mr. Groom. You ready for it? You ready for it?
Yep.
All right, check this out. Well, I'm going to change, well, I guess kind of two things, but watch this. Watch, wait for it. Caleb's not here today?
He had a doctor's appointment and his first 2 periods were nothing, so he just decided not to come.
Oh, I hear that.
Huh? Yeah, he's supposed to be there.
Oh, so we're not doing a debate today.
He might be there for that.
It's his things that was very much his fifth period.
Literally, what are we gonna do to this citizenship?
What are you doing?
He was supposed to have a
He said he
debate,
was-
but we're doing a Democrat versus Republican discussion.
No, it's pro versus con, but yeah.
No. What we're
since
doing
we're
in
not
citizenship
doing
after the debate is like a Democrat versus Republican, and we're checking out textbooks.
All right. What is the antiderivative of 1 over x squared plus 1? Wait, we should look at the graph first. What does this graph look like?
Magic? Yeah. Why is
Like
it
that?
magic?
Is there a problem at 0 this time? Doesn't look like it. Because we got that plus 1 on the bottom, so we're probably good now. It looks just like this fella. Does it look like it might have a finite amount of area? It looks like it's going to 0 pretty quick, so it looks like it's possible. What is the antiderivative of 1 over x squared plus 1? We should recognize him.
Oh.
Alright.
Something about tangent.
It's arctangent!
That's what it is.
You are amazing, lady.
Recognize it.
That's right.
Not a lot.
But dear, before I get carried away, what I probably should do is remember I need to evaluate that from negative infinity to 0. And then I need to do that, and I need to plus 0 to infinity. Okay. Now, let's do this thing, shall we? Okay. What does arctangent look like? It's been a while since I've seen it. Remember? What does arctan look like? We should probably graph him. Oh. Sorry. That you did tangent, dear. That's tangent. And you arctan.
It does this.
Your dadgum right, it does that. So what happens at 0, friends? What happens at 0? It's 0. Minus the limit as x approaches negative infinity. Now what happens to arctangent as you approach negative infinity? If you trace along here, you will see that it's about equal to what? By the way, this is why I hate calculators. Well, 1.57, 1.57. Yes, aka negative pi over 2. Plus, now obviously the limit as x approaches infinity, arctan of x minus 0. And this guy also approaches pi over 2. So negative and negative pi over 2 plus pi over 2 is pi. meaning all this area, now you're like, meaning all this area all the way out forever, plus all this area equals pi? Nobody said that. No. This area adds up to pi. See the difference? People oftentimes get hung up on this. If you're anti-derivitating this, you're finding the area under this fella. Yes? And you're doing that by doing the antiderivative and then evaluating it here and here. And so you're not evaluating this, you're evaluating it here. And what's happening to it is you head out here, and then here, and what's happening to it is you head way out there. And on this end, it's adding up to pi over 2, negative pi over 2, and positive pi over 2. But it's minus and minus, so plus. So it adds up to a total of pi units. What's the matter? Next week, one of my favorite things, we're going to get to do our very own PDFs. And a PDF is such that if you integrate it from here to here of any function, it equals 1 every single time. Okay, that is the definition of a PDF. You remember that from last year? Stats? Yes, you do.
Yeah.
So, Mr. Groom, could I make my very own PDF? Sure. You know what this one will have for an area when you're done? You know what it'll have for an area when you're done? 1. Right? It was pi a minute ago. It'll be 1 now.
What? The PDF? Like
PDF.
You don't mean like the
Probability density
Oh, okay.
function.
See, I was going for the vector file.
I was too.
Vector file.
Like a PDF file.
Oh.
Document. That was
Probability density function. My bad. PDF. You could make your own. It doesn't even have to go all the way from infinity to infinity. Watch this one. Mr. Groom could actually do this one. This is my PDF. From 0 to something equals 1. What would that something have to be? I don't know. But this is x squared. From 0 to something is equal to 1, yes? So that'd be like a squared minus 0 equals 1. So then a would equal what? 1. So, I mean, here's my equation. Boop. That right there, that's my PDF. What does it mean? I don't know. I just made one up. But in statistics, you have real, actual ones. By the way, they're really awesome and real and cool. That also makes it, by definition, gross. I'm going to get suspended for this.
That's what I said.
I'm going to get suspended.
She said if you want to get paid, you need to give her a check.
I know.
She said it real saucy.
lied about the chance too. Always.
Yeah, and Mr. H thinks I'm stupid now because I said, Mr. H, Mr. Groom insists there was a black bag of candy.
I didn't say
right?
black.
Yes, you did.
I said a big bag.
No, you said a big black bag. And then he goes, that bag was not black, and that bag was clear, and that bag's not here. And I was like,
I never said it was black. You don't listen.
okay, someone that listened to the phone call did not say black.
Nobody heard it. He was on it. He wasn't on speakerphone.
We couldn't hear you, but he didn't
Yeah.
say
He said
black.
black.
He said green a lot.
Big.
The green engine, next to the green engine, the black bag. Next
Oh,
to
a
the
big
green
bag.
engine.
The big bag.
I don't think
Big
he
black
said black.
bag.
I think you heard
He
black.
said big black bag, did he not?
I'm pretty sure I heard you say black bag at one point.
I'm with you on this.
I'm not.
It's okay. But as long as H said it's gone, it's fine.
Yeah,
It was there by
I
lunch.
double checked.
Okay. It was there at lunchtime, so I just want to make sure I got taken care of.
I have some questions.
Yes. Oh, let's do a homework question. Hit me.
But I have a question that's
Oh.
not related.
Okay. Okay.
Who's teaching calculus next year?
It's like 99% sure Mr. Foster's going to take over. Foster. Foster, new guy. That's it, man.
We may or may not have AP chemistry or physics.
Yep.
Really?
Because there's not enough, there's like
We might not.
between 4 and 7 people signed up for AP Chem. And then there's also 2 teachers teaching it. So,
Yeah, but there's more people than that signed up.
By the way, did you realize how many zillion different classes they had this
they're
year?
also adding classes.
They're adding a bazillion classes. By the way, none of which are going to fly. Oh, here's a fun one. What?
The computer science class?
The walking one is great. Yeah. No, there's one. Yeah, Miss Amelie, what's her face, Rousseau, the cooking gal.
Yeah.
There's literally 190 kids or something signed up for teen cuisine. Maybe 200. It's a ridiculous amount. Plus French and international and Spanish. Oh my God, there's like 18 cooking classes with like 800 kids in them. I'm like, well, good grief, they can't all fly. So obviously those kids are going to get weeded out, and where they end up will end up in some random place. No, they're not going to end up in AP Chem, but they'll end up in random places. Like all these other classes are really low. Like some of the art classes are low. My auto ones, I'm down about 15 kids or 10 kids from where I should be, but that'll come back up because people are going to get tossed out and have to go somewhere. Oh, take this class, take that class. It's ridiculous. They shouldn't offer all these ridiculous electives. Well, we should be a full service program. You don't have enough kids anymore to do that. Sorry. Yeah.
Your school district going down?
Yeah. Well, you lost all the big jobs that were out here, and people moved away, and then there's, I don't know. And then apparently there's a big slug of kids coming in 6th grade, so it'll pop back up for a year or two, and then back down. I don't know. Yeah. We were up to like 1,200 for a while when we were in the Three Rivers League. It was ridiculous, playing against Lake Oswego and all them. And getting our butts kicked by Lake Oswego and Lake Ridge. And well, Lake Ridge, they sucked. Lake Oswego, Oregon City, West Lynn. That was great. Playing at West Lynn one time, this kid on our team just gets, oh my God, he got clipped so hard. The guy just buried his face mask into our kid's back, and the kid's laying on the ground crying for crying out loud. So I ran on the field after, because I'm screaming at the ref and he's ignoring me. So I got there and I think, what are you doing on the field? I'm like, what do you think I'm doing? Kid's hurt. You came in. Oh, I rip his pants and shirt apart like this, like just like pull it up like this, and there's like face mask bars in his back. I say, that's clipping! And I'm screaming at him, right? Next play, we get called for clipping. And I go, well, at least you know what it is now, don't you? Yeah, got another 15-yard penalty. Yeah, it's all right. I don't care. Made my point. All right, go ahead. I used to scream pretty loud. It was pretty funny. Yeah.
Why are you still the football coach?
Oh, I was just JV back there, a freshman with Mr. Patterson. I used to coach up in Idaho. I don't know, I just lost my passion for it. Plus, it feeds my anger.
It's so much more amusing if you know this. Okay,
I-
that's
Really?
Yeah.
Yeah,
If they don't do anything, it's not fun to watch.
They don't scream? Like,
They don't do good plays.
oh, well, it's,
I heard they have the same playbook from like for the last 10 years or something.
Grim could coach softball.
That's what I was doing. Anyway, 15.
He'll FaceTime you all the time. He'll be like, okay, Taylor, what should I do?
Integration by parts.
okay.
And it's the integral of e to the negative x sine x.
What page, what number?
Page 404, and it's number 15.
Yeah. The problem with that is it kind of fed into my anger problems.
That's okay. Number 15, you said?
I broke my hand one time. I didn't even mean to. I was just making a point at halftime. My hand was frozen because it's like 15 degrees outside. And I was like, come on. I smacked the board, you know. And it didn't even hit that hard. And then after the game, I'm like, why is my hand hurt? And it swelled like a pumpkin. And when I could feel it again, I'm like, oh. And I got yelled at when I got home. I'm like, I didn't even punch the board. I just get it like one of these open-handed jobs. And I couldn't write for like 2 weeks. I'd like do this number on the board. It was horrible. All right. So who's DV and who's you?
So
Well, I
dv
did
would be
pass
sine
off.
x.
DV.
I mean, no, u is sine x.
There you go.
And dv is e to the negative x. Yeah, that's what I did. Okay. So v is e negative, yeah. It's negative cosine x, right? Or cosine x.
So UV minus the integral of V du. Now what? Do it again. Ah, da, 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 da. Right? Come on, you hippie. UV, so negative E negative x cosine x minus the integral of V du. Negative, 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 still negative. Okay. Now, that, my friend, is what we started with, isn't it? That's what we started with, isn't it?
Yeah.
It is time to get off the ride. We've seen all there is to see. We came, we saw, we conquered. It's time to go home. How do I finish this problem off?
I don't know.
You add.
Yes. Right?
Why do you do that?
Because now I have this. Is equal to 2 times what I wanted to find the answer for, yes? Well, that's not what I wanted. I wanted one of them. So divide by 2. And then if you would be so kind as to throw a plus C on there, you'd be good to go. That will always happen when you have an E and a trig function going together. Go around 2 times on the ride, then get off. Believe you me, I have gone around more than that back in the day when I was young and stupid. Oh, I'll just keep going, it'll keep working. No, it's not going to do anything else. You've seen all there is.
First one, and then I like to go back and forth, so I stop. So it's
Can I go over? I'm not that fat, Abby. I'm not in the way.
Well, I have this person who saw me and got this
Jeez, Abby's. Okay.
I also have one 27.
27.
It's the same page. So it's also integration by parts. And
Okay.
the integral of arc cosine x. Cosine of the curve is the last one.
Wait.
There's a trick.
Wait. Li-a-te. What does the I stand for?
Inverse.
Nice. Well, that leaves dv to be what?
1.
dx. 1 dx. Yeah. Nice. Listen, I'm on a deserted island. I can't remember what the derivative of arc cosine is. So I do this instead. Are you with me?
Yeah.
Yes. What is the derivative of cosine of u? Minus sine u du dx. Yes?
Yeah.
Equal 1? So du dx is equal to 1 over minus sine of u. Well, that's cute, but what is the sine of u, Mr. Groom? Well, I don't know, but I know the cosine of u is equal to x. Cosine is here and here, yes? Ergo, this must be this. True that? So then it's 1 over the sine. Now, what is the sine of u up here? The sine would be this feller over that feller, yes?
Yeah.
So 1 over would be this feller over that feller, yes?
Yeah.
So it'd be minus 1 over 1 minus x squared. Or you could look in the front of your book if you wanted to and get that, but it's in the back of your book. But there it is. Right?
So like on a test or something.
If I was going to ask a question like that on a test, I'd have to give you a table probably for it, because I'm not a horrible. I'm not. What is Shrek called? I'm not an ogre. Yeah. Most of the time.
Hey, don't no.
What'd you say, girl?
It's another one of Grimm's rules.
Say anything.
I wish.
Okay. I'm going to pull this negative out front if that's okay. I'm going to do it anyways. I don't care. It's minus minus, right? Now what? How do I integrate that last part? Say it. Well, I might say it wrong. I don't want to.
Because that's what I'm thinking of. That's what I'm thinking.
No. Could I do trig substitution?
Oh.
I could. Is there an easier way? Could I do regular substitution? Could u be, if I was going to do regular substitution, u would be who?
1 minus x.
That's right. And then du would be what? Negative 2x dx. Well, I don't have that. I have negative half of that, right? Right? So I have x, oops, stop it. I have x cosine x, inverse cosine x. Okay, and then if I do this, this is really going to be what? It's the integral of negative a half u to the minus a half. Are you leaving? Have a nice day.
Thanks. I'm gonna go see my dad.
Oh, bye.
Bye.
So this is u to the half. Divide by half, which is the same as times u by 2, correct? And there's already a negative half out front, right? So it's going to be minus the squirt of u. And the squirt of u is what? Well, u is this. Ta-da! By the way, could I have done that with trig substitution? I could have. I would have let x equal sine of u. X equals sine of theta, I mean. Right? And then I would have ended up with cosine squared of theta in the bottom. Then I would have square rooted that, and I would end up with cosine of theta. And then I'd have had sine of theta on top. Cosine over sine is tangent. Right? And then the integral of tangent is something, something, something. It would have come out to be the same exact answer. It's just a messy way of getting here. All right, what's your question, girl?
Oh, so mine was on the long division worksheet, and it was number 2.
What's it say?
So it's 3x minus 1
Super long. Yeah.
over, and then it's x plus 5 times x minus 6 times 2x minus 1.
It looks like this. You want it?
That's not long division, my dear.
That's what it says.
No.
Well, it says it, but it's
It's partial fractions.
Probably why I was confused then.
Okay, what is the rest of it? I don't know. Is it really?
It's on the long division.
Yeah.
There are multiple of them.
I
Like
was
1,
very-
2,
What do you get? X minus?
X plus 5,
2 of them.
x minus 6, and 2x minus 1.
Alright. You gotta hurry around out of daylight. So we're gonna get 3x minus 1. Two ax squared. So minus 6, minus 12, minus 18 ax's plus 6a's plus 2bx squareds 10 plus 9bx. That's x squared plus cx squared minus cx minus 30.
Isn't it just on the A axis? Isn't it 12 and
There's negative 12 and negative, oh,
it's 12?
negative 13.
Yeah. Okay. There we go.
I wonder if I screwed that up over here too. Nope, I got that one right. Alright, so 2a plus 2b plus c equals 0. This lady in my class, I don't know where she's from at OIT. I don't know. She's not Korean. Vietnamese maybe, I don't know. But she's an older lady. Anyway, she didn't speak English very well. And she's like, can you not talk so loud? That's the first I ever heard that. Talk too fast? Yes, but I never heard talk too loud. I don't think I'm that loud most of the time, am I? Yeah.
That was really random.
Yeah. It was just like after a class. That's what she came to me and told me. And I'm like, oh, well, I'm sorry. I guess. I just didn't want to be all offensive to her because apparently I was too loud. This is a C there, yo. Don't forget that. So 6A minus 5B minus 30C equal neg 1. And this equals 3, right? Gross. Let's just add these first two, okay? Let's just add them, aight? That's cool. Oh, it's gross, dude. No matter what you do, you're hurting here. Well, you just gotta bite the bullet and do it, I guess, Jay. Let's times this feller here by negative 30, huh? Or positive 30. Positive 30, right? Positive 30? Because I need to get rid of C. If that's what I'm going to get rid of, yes? And then plus 270B. Ugh. And then plus 30. Wait. What? Just wait a minute. What happened?
You have to multiply by negative.
No, Mr. Groom's a moron. Listen, stop. You're freaking me out. I need to multiply this one here. Oh, I was doing it right. Never mind. Negative 390A plus 270B. And then minus. Oh, well, yeah, I should have been positive. Goodness sakes. So I wanted to multiply by negative 30, so that's going to equal negative 90, yes? So these become 396A, gross, minus 275B, gross, equals, what, negative 91? Sick. That's just sick, dude.
Why did you write You did this, right? You made this one?
Yes.
Why?
I don't know, because I'm an idiot.
Were you not expecting us to do it?
Is 11 going to 275 there? Is 11 going to 396? Please.
75 divided by 11. It does work.
How many times? 25.
Yeah.
Yes! Times the top one by 25, yo. So 275A plus 275B equals 75. That's probably why I did it. I'm going to pretend that's why I did it. Cancels. This here becomes 11, carry the 1 to 17, carry the 1, be a 6, equals 16. So A is 16/671. It's a good sized number. What is, yo? Neg 16, thank you. Whew.
Okay. Oh, that's right.
Yeah?
Is that what you got?
Nope. I didn't finish it, so I got 2A, but I went a different route, and I also did one little.
So negative 11 times that. Riley, do this on your calculator, please. So it's 167. So here, don't do anything yet here. It's 167 over 671 plus 11B equals 3. So do 3 minus 167 over 671. It's 11B. What did you get?
0.75.
Divide that by 11.
0.25.
Exactly?
Well, it's 0.25 dollars.
Oh, it's close enough for government work, I guess. So there's my A and my B. I just plug them back in up here, I guess, and find CA. That's handy.
Okay, nice.
So 2 times, I'll rewrite it for you.
Okay.
Plus 2 times 0.25 plus C equals goose egg. Tired. The x minus 6? Yeah. What's the last one? What'd you get?
Negative 0.452.
0.452? Okay, be careful. It's 1 over 3x minus 1, huh? Is that right? 2x minus 1. So be careful. It's not just ln. What do you got to carry for out?
Wait, no, it was 3x minus 1.
What?
It was 3x minus 1.
Oh, so I used 2. Was it 3?
Oh, no, that.
It's 2 on the bottom.
No, I looked at
So then remember this, you have to use u substitution, yes? There's going to be another half floating around, isn't there? You with me? Right? So then just be careful. Boy, I'm hungry. No. I know, dear, you're right. 0.2, what's half of that? 225? 226, I guess? ln 2x minus 1 plus c. I just made that problem up, so I don't know how ugly it's supposed to be. Is that what you got?
Isn't it 3x minus 1?
On the bottom, dear, it's 2x minus 1.
That's the same thing.
Yep.
Minus 27?
226. There's no big black bag that looks like me up here, Mr. Goob. That's so cute. Is that good? I'm sorry I was so ugly. And I said use long division because I'm stupid. Long division.
Oh, thanks, Abby.
Long division. Integration by parts. An easy trig substitution. What else? What else?
That's it.
Parts, long division. Oh, long division. Did I say long division already? Parts, long division, partial fractions. That's what I missed. And trig sub.
How long will it be to do before
Like 4 questions. That's okay. Probably. If I was a betting man, yeah.